So good afternoon everyone, and today we'll start our discussion with vector calculus. So what is a vector? What do you mean by a vector? A vector is basically a quantity with value with its magnitude and direction, right? A constant vector A that will be generally denoted by a1i plus a2j plus a3k. It denotes the it is denoted in terms of the component along x, y, and z axis, where this I, j, k are the unit vectors along along x, y, and z axis. Now, along with that, what you have learned? You have learned the dot product. Dot product you have learned. What do you mean by dot product? If you have two vectors a and b, then the dot product a dot b, that is going to be equal to mod a into mod b into cos of theta. That you have learned. Next, what you have learned? You have also
Yes.
learned cross product. What is a cross product? Cross product is basically a cross b, and this has the expression will be denoting by ijk, and then there a1, a2, a3, and if b has the component like b1i plus b2j plus b3k, then it will be b1, b2, and b3. We have also learned triple product of the vectors, right? What is the triple product of the vectors? If we have three vectors a, b, and c, then we have two different type of triple product. One is the scalar triple product, that is a, b, c. It has the meaning. It has the meaning. It is a dot that one a dot b cross c. It is a dot b cross c, right? Am I correct? So I should not write that third bracket. This one, right? A dot b cross c. We have also learned about uh, vector triple product. What is that? A cross b cross c. Have we learned it or not? What is the vector triple product? C minus c
A dot
into
C
a
into
dot
A dot.
b.
Okay.
So these are the things, the basic things that we have already learned. And again, we also have learned about the cross product. Uh, Cross product has another meaning or another expression in terms of the component this way. What is that? Mod A, mod B into
Sin theta and cot.
sin theta into n cap. That we have learned. Yes, no? Yes or no?
Yes, sir.
Yeah. So due to this particular result, we also know that if we have two vectors or if two vectors are parallel, then suppose A and B, if A and B are parallel, then A can be written as K into B, right? So A and B are parallel. A and B are parallel. And when they are uh, they are basically perpendicular to each other, then what happens? A cross B, sorry, A dot B equal to 0, right? If they are perpendicular, then A dot B equal to 0. This we know. This much we have learnt or not? Yes, no?
Yes, sir.
Right.
Yes.
So these are all about the constant, like A, B, C. These are constant vectors. For that we can do those things. But whenever it comes with a vector function or scalar function, then what to do with that? Even suppose if I am having a function like r, which is the function in this way r1I plus r2j plus r3k, for r to be a constant, then this is well and good. Now if r is something a function of t, where r equal to r1ti plus r2tj plus r3tk, in that case, if we talk about the derivative of the vector r dot, or this is basically dr by dt, then it will be calculated by what? dr1 by dt I plus dr2 by dt j plus dr3 by dt k. But if this r becomes a function of three variables x, y and z, if this becomes a function of x, y and z, in that case what you are going to do? How to define the dr by something, because here you are having three different vectors. What about the derivative of these vectors? So these will be dealt with by this vector calculus, information about or knowledge about vector calculus. Just let me insert some more pages here. Now to know about this vector function or vector function, we need to know two more terms. One is called scalar point function, and another is called vector point function. Now, if you are in a three-dimensional space, we have already studied the calculus of function of several variables. There, by a function at a point p x y z, by a function f of x y z, what we mean? There will be a domain. Suppose this is three dimensions, means on space. So in this case, it will be in space. On space, some point. This point will be basically having coordinate x, y, z and z, and corresponding to each point this x, y, z in a domain. If we can have, in suppose there is a w plane, w equal to f of x, y, z. If we can get a function, a point w corresponding to each x, y, z, we can find a w, then this f will be called a scalar point function. And if this w be a scalar point, means there is no direction. In scalar you have only magnitude, no direction. If this happens, we can find a scalar or unique scalar number w, then we will be calling this w or f of x, y, z to be a scalar function. But what about a vector function? Vector function is basically for each point this x, y, z, suppose p, x, y, z in three-dimensional space, if I can correspond a vector, not a scalar, but a vector f of x, y, z, where f is consist of three component, f1 of x, y, z I plus f2 of x, y, z j plus f3 of x, y, z k, then we will say f is a vector point function. Okay. Now whenever we will be having a domain, suppose r is a domain, or what I'll say, yeah, it's a domain. Since we are having a function on a domain, such three-dimensional domain like a surface like a spherical thing, spherical ball, or it's a cylindrical object, anything in three dimension. If r be that kind of surface or object or domain, and on that domain, if we are defining a function f, then this R will be called the vector field. This R with this function f will be called a vector field. Okay, like your partial derivative, here we are going to define the grad operator. Grad, or it is sometimes called gradient. Its symbol is del. It's a reverse del. Sometimes people call it del, or this is called nabla also. And whenever we give it a vector form, this this is known as the del operator, vector del. And what is the expression for this? The expression for this is, so this is an operator and it will be having form del del x of I plus del del y of j plus del del z of k. So this is the vector differential operator nabla. Okay. Now what is the utility of this? First of all, whenever we will be applying this vector function on a suppose scalar point function phi. Suppose phi is a scalar point function f of xyz. Now phi don't have any other component. So whenever we will be writing del phi, this will be basically del del x of I, sorry, del del x I, del del y j, and del del z k. This operates on, say, phi. This will give you del phi del x I plus del phi del y j plus del phi del z k. Okay. Now see, a scalar point function, whenever we are operating with nabla, we are getting a vector here. This vector is not just a ordinary vector, it has some meaning. If you are having a surface here like phi, and suppose this is a point xyz, then this nabla phi, that represents outward drawn normal to the surface, normal vector to the surface. So this nabla phi, that is the outward drawn normal to the surface of phi at a point xyz. Sometimes your question might be in this way. You might be asked this question, that you will be given a function phi. Suppose phi of xyz is given, and the question will be, find the outward drawn normal to the surface phi of xyz at a point, say, some alpha, beta, gamma. So if you are having this question, then what you need to find? You have to find the solution in this way. You need to first find, you have to first find what? Find the grad phi. Okay? And grad phi, then you put this xyz equal to alpha, beta, and gamma. So whatever you will be getting, that will be your normal to the surface. Is that okay? Is that clear? Don't worry, I'll take some example, but before that let me discuss the theory, then I'll be going for the outward drawn normal to the surface. Is it clear to all?
Yes, sir.
Good.
Yes,
Thank you.
sir. Yes, sir.
Thank you for your response. Next, sometimes the question may be having some twist. Like you'll be asked, find the find the unit normal to the surface phi at a point alpha beta gamma. Unit normal to the surface at a point phi surface phi at a point alpha beta gamma. In that case, what you need to do? Basically, in that case, you need to first find grad phi. As you know, grad phi is a vector. Suppose A is the grad phi vector. Okay. Then I need to find the unit vector along the direction of A. And what will be that? Anyone? Suppose n cap be the unit normal in the direction of A, then what will be the n cap? Anyone? What will be n cap?
N vector by magnitude of n.
Right. Thank you. So it is A divided by mod of A. Right? Is that okay?
Yes, yes, sir.
So this is one of the very important result, because this result is also needed to find some more problem, to solve some more problem. So this is the unit normal to the surface. So basically this n cap is equal to the vector grad phi divided by mod of grad phi. Remember, this grad phi is a vector, so that's why I am taking modulus here. Okay. Now have you uh, have you ever faced this problem, that find the projection of a vector along any vector?
Yes, sir.
Now this how you find? Suppose you are having a vector A and you need to take projection along, or projection of the vector A along the vector B, then how you find the projection? So
Sir,
basically,
A dot B by magnitude of B.
right, thank you. So what do you mean by projection? Basically, suppose this is the vector A and you are taking projection along B, means this magnitude that you need, right? Yes or no?
Yes, sir.
And how we calculate it? As you are telling that projection equal to what? A dot B divided by mod
Magnitude of B.
mod
mod
mod B.
नहीं बस B.
Mod B होगा.
हाँ mod B.
Okay, mod B. So if this is theta, you see, let me show you where from you are getting it. So projection of A, if you try to find projection of A, if you want to find, then what will be the projection of A along this direction? If this is the direction of B, then it is basically mod A cos theta.
Yes.
Right. Now if you have two vector, then the definition, from the definition of A dot B, what you know? A dot B equal to, it's mod A
Mod
mod
B.
B
Cos theta.
mod B into cos theta.
Yes, sir.
So I want what? So therefrom what will be the cos theta? Cos theta will be
A dot B
A
by
dot B by
mod B.
mod A into mod B. Now if you try to find this one, mod A cos theta,
A
then
dot
what
B.
will be equal to this? Mod A into A dot B, or this will not be there, A dot B divided by mod A into mod B.
Mod B.
So A will cancel each other. Ultimately, what you are getting? It is
Projection
A dot B divided by
mod.
mod of B.
mod of B. So basically, the projection of one vector along another vector means you have to take dot product along the vector, along the direction of the vector. So actually, what you are taking here, A, if you try to separate it, it becomes A into, it's the unit vector along the direction of B, right? A dot unit vector along the direction of B. Clear?
Yes, sir.
Now in this connection, you have a directional derivative or directional derivative. What is the directional or directional derivative? The directional or directional derivative is basically derivative of a vector, suppose of a scalar phi along a direction, suppose a1I plus a2j plus a3k. Suppose your vector is A, along the direction of A, along the direction of A, the directional derivative of phi, that will be basically the projection of this grad phi along A. Got the point? What is the directional derivative? The directional derivative is the projection of nabla phi or del grad phi, del phi or grad phi along the direction of A. And how to evaluate it? So it is going to be grad phi into A cap, that is vector A divided by mod A.
Mod A.
That is the directional derivative. Now sometimes also question comes in this way, in which direction the directional derivative has the maximum value. You may note down the question, in which direction the directional derivative has the max value. Okay, can anybody tell me which direction it will be having maximum value?
Parallel axis of A vector.
Right. So
Both sides.
basically suppose this is the vector, this vector I am considering as your the grad phi. Suppose this grad phi is equal to the vector r. Okay, this is a variable vector because phi consists of function of x, y and z. Now if I want to take the directional derivative, that means I want to take the projection of r along the direction of A, then what I do, r dot A cap, that we try to find, that is what, r dot or r
A by mod A.
mod r, basically mod r cos theta, right? So the whole thing depends on theta. Whole thing depends on what? What we do here, r dot A means, just in the previous we have already discussed it. What we have done, this one, no, A cos theta, that is the projection, and that we have calculated by A dot this by this, that is A dot unit vector. Here we have done r dot the unit vector, and that is basically r cos theta. Now this depends on the value of theta. Now in which or for which value of theta cos theta gives you the maximum value? Whenever theta is equal to
0.
0.
for theta equal to 0, this mod r cos theta is the maximum So, and this is possible only when you are taking the directional derivative along the direction of grad phi. Okay. Sometimes question also may come that find the max value or maximum value of directional derivative at a point. Point, say suppose alpha beta gamma. So in that case, what you have to do, you need to first find this grad phi at alpha, beta and gamma, and say suppose this vector you got as A, then you need to find what? Unit vector along this direction. So you need to find A cap. This will be basically grad phi by mod of grad phi, and then you take the product A dot A cap. So whatever you will be getting, that is your max value. Is it clear?
Yes, sir.
Yes, sir.
One last type of problem which can come from this application of this gradient is that find the angle between two surfaces at a point. So surfaces suppose phi 1 and phi 2 at a point, say alpha beta gamma. So suppose you are having two surfaces here, this is one and this is one, and they meet at this point suppose. Now if the question is to find the angle between the surfaces, okay, angle between the surface of interaction, what we need to do is first find the grad phi, and say at this point the grad phi for this particular surface will be like this, the direction, and this surface will be like this, right? And whatever the angle will be there, that will be the required answer. Say if this point be, this particular point be alpha beta gamma. Okay, say this is the surface phi 1, this is the surface phi 2. So what I have to do, first of all I will be finding grad phi 1 at the point alpha beta gamma and grad phi 2 at the point alpha beta and gamma. So we got two vectors, say this is A and this is B. Now what I need to do, I need to find the angle between the vectors. And what is the formula for finding angle between the vectors? You know that from the definition of dot product, I know that A dot B equal to mod A into mod B into cos theta. So cos theta will be equal to this A dot B divided by mod A into mod B, and so that theta will be equal to cos inverse of A dot B divided by mod A into mod B. Is this theory clear to all?
Yes, sir.
Good.
Yes, sir.
So I'll be giving you some of the problem, or even you can see in my practice sheet. If you have already received that, you will see there that the problem of that kind is already there. How many problems I have told you right till this point? Find the directional derivative, it is one type of problem. Find the uh, outward drawn normal to the surface, that is one. Find the directional derivative, find which directional derivative is the maximum, what is the maximum value of directional derivative. So these are all different types of problems that you are going to encounter with here. Okay, is that clear? Am I audible?
Yes,
Yes,
sir.
sir.
Yeah. So because of yesterday's experience, I have to every time think whether I'm audible or not. Though I'm from my home, so here you will not have interruption, but sometimes it may so happen in that way. Okay, yes. One more type of question is that find the unit normal to a surface at particular point. So after finding grad phi, you need to particularly put that point and get the answer there. Okay, don't worry. I'll be sending you the solved example. It will be uh, useful for you. Next, you have this vector differential operator grad whenever it operates on a vector function like grad of f. Suppose your f is a vector point function like f1 of xyz I, okay, sorry, no, it problem, plus f2 of xyz j plus f3 of xyz k. So what will be if I so with the whenever nabla will be operating on a vector, there will be two types of operation. One is that nabla dot f and another will be this nabla cross f. Whenever it operates nabla dot f, this is called divergence of f and this is called curl of f. Curl of f. Curl means it gives the rotational property of the vector field f, and divergence gives whether it is a source or sink or solenoidal, this type of thing. As you can see, so whenever you will be finding divergence of f, it will be basically del x of I plus del y of j plus del z of k. This dot, whenever you will be doing f1i plus f2j plus f3k, then what you are going to get here? It will be del f1 by del x plus del f2 by del y plus del f3 by del z, right? You can see this is a scalar quantity, right? Now, depending on the value of this scalar, that is nabla dot f, it can be equal to 0, it can be greater than 0, or nabla dot f, it can be less than 0. If nabla is equal to 0, nabla dot f equal to 0, or divergence of f is equal to 0, then f is called solenoidal. You know solenoid? Do you know what is a solenoid?
Yes, sir.
What is a solenoid? Solenoid is a field where the vector field are not going out or coming in. What you will find? The vector field will be, it is not like this, like source or sink. It will be rotating and field will not be going outside. It is called solenoid. Okay, and solenoidal means there will be the vector field will be equal to 0. Sorry, divergence of the vector field will be equal to 0, and if nabla dot f is greater than 0, then f will be called source vector. What do you mean by source vector? Exam hall में क्या देखे हो तुम? What you have seen in exam hall? If you have a good student writing the exam, from him all will be copied, right?
Yes,
Last
sir.
time in the class test it happened.
Yes, sir.
So that particular student is the source vector. Okay, his divergence is greater than 0, positive divergence. Okay, and suppose someone is a very weak student in mathematics, but he is a very popular student in your class. Then what will happen? Other people will be trying to help him or her,
Yes, sir.
right? So all will be trying to help him or her, means there will be help coming from outside.
Probably every side.
So
Yes.
he or she will be a sink. He is taking everything as a sink. Like what water sink. What happens? Through a pinpoint or through a hole, everything is going draining out. So that will be looking like a sink. So this, in that case, F will be called sink vector. And I hope your physics teacher also have explained this source and sink, right?
Yes, sir.
Good. So here from the kind of question that you are going to get is that you will be given a vector in terms of some constant, like maybe xyz kind of thing will be involved in the function, and you will be asked find the condition for which a given vector or the particular given vector is a source vector or it's a sink vector. Okay, or prove that some vector will be given and will be asked prove that this particular vector is a solenoidal vector. Okay, like let me take a quick example. I got that example. Determine the constant m such that the vector v equal to x plus thrice y I plus y minus twice z j plus x plus mzk is solenoidal. I'm sorry about my handwriting. I cannot, that means I cannot help with this handwriting. You have to understand. If you don't understand, then you try to listen to my voice, what I am trying to say. Okay. Will that be fine for you? Okay. So if this is there, this type of problem is there, then what you need to do? So first of all, you will be finding the divergence of V. That is nabla dot V. And what will be it? It will be basically del x of x plus thrice y plus del y of y minus twice z plus del z of x plus m into z, this one. And by condition it is solenoidal, so this will be equal to 0. So that here from what will you get? 1. This del x of 3x x plus thrice y, what will be that? 1 plus here del y of del y of del y by del, that is 1 plus here m into del z of z, that is equal to 1, that is equal to 0. This will give you m equal to minus 2. Clear? Is that okay to all?
Yes, sir.
Yes, sir.
Good. So there are some properties. The properties are not that much important because these are straightforward. Like since it is a vector, it's a differential operator like the d operator, d dx. So addition of two, that is divergence of two vectors v1 and v2 will be equal to divergence of each of the individual vectors, like that. So I'll be listing the list of properties. Now there is another operator. This will be widely used whenever you will be in the next semester, that operator is named after Laplace. Laplace operator. This operator is no more a vector operator, rather the Laplace operator is a scalar operator. What kind of operator is this? It is del dot del operator. So basically what will happen? Del del x I plus del del y j plus del del z k. On this, if you operate this one, again del del x I plus del del y j plus del del z k, then what will happen? You are going to get here del 2 by del x2 plus del 2 by del y2 plus del 2 by del z2, and this is denoted by nabla square. This is called the Laplace operator. Is that okay?
Yes, sir.
Good. Next, we want to talk about Carl. So, would you like to have a break or should we continue?
Continue, sir.
At the time, whenever you will feel that boring, you can just tell me, sir, please stop, we need a break. Two more topic is there. One is that curl of a vector, and then I'll be going to talk about vector integration. Okay, and that will be ending somehow, that will be covering up the whole syllabus. Okay, curl of a vector. Curl of a vector is basically defined by nabla cross the vector f. It is denoted by also curl of f. So what is this? It will be operating like a vector. So it will be I, j, k, then del del x, del del y, del del z, and if here f1, f2, and f3. Now if you expand it, then what you are going to get here? Okay. It will be I into del f3 by del y minus del f2 by del z plus or minus I j into del f3 by del
Del
x minus del f1 by del
del
z plus k into del f2
2.
by del x minus del f1 by del y. So this is the expression of curl of a vector, and this has a physical meaning that this defines the rotational property. Rotational property means uh, it will be giving you the angular velocity, twice the angular curl of a vector, that basically gives you twice the angular velocity at a point in a vector, for a vector field. Okay, now how we are finding it, let me show you that. So suppose you are having a vector which is having linear velocity in this way, angular velocity in this way, omega equal to some omega 1 I plus omega 2 j plus omega 3 k. And suppose r is a linear vector of which The expression is R1I plus R2J plus R3K. So sorry, not linear velocity. This is the Poisson vector of any point. Now, if v be the linear velocity, v be the linear velocity, then you know the relation between linear and angular velocity. What is that? The linear velocity v, that is equal to omega cross r. Omega cross r. Now let us see how what happens by this. That is v equal to what happens. What will you get? You are going to get here. It's I j k. It's omega 1, omega 2, omega 3. It's suppose r1, r2, and r3. So this will be equal to then how much? I should not write here r. It will be confusing. Position vector, na? Suppose xyz is there.
R1, R2, R3.
This be xyz. Suppose Poisson vector, na? Otherwise it will be looking like a constant. Let it be xyz. It will be easier for you to understand. Xyz is the Poisson vector of any point. Okay. Now at this point we are finding the linear velocity, and this will be having the expression what? You see, I into it's w2z minus w3y plus j into w3x minus w1z plus k into w1y minus w2x. So I think we have done a mistake earlier. What was that? This should be plus, right? Yes or no?
Yes.
Yeah, that will be plus. Okay. Now, if v be this vector, then what will be the curl of v? This curl of v, that is will be equal to this I j k, then this is omega 1, omega 2, omega 3, sorry, not omega, it is del del x, del del y, del del z, then here omega 2z minus omega 3y, here omega 3x minus omega. I have to write it in a bit clear way. Okay, let me write it. So this is I j k, it's del del x, del del y, del del z, here omega 2z minus omega 3y, here omega 3x minus omega 1z, and here omega 1y minus omega 2x. Now if you expand it, then what you are going to get? You see, I into del y, del del y of omega 1 y minus omega 2 x. You see this omega 2 x, this portion will be basically 0. Only you will be getting here omega 1. Similarly, this whenever del del z of omega 1 y, this will be there, this only will be there, so omega 1 into omega 1. Likewise, j into, you will get here omega 2 plus omega 2 plus k into omega 3 plus omega 3. So basically here what you will get 2 into
স্যার এই লাইনটা বুঝতে পারেন না, বলুন।
Acha. So then I have to expand it. I have to expand it again. Let me expand it. If it is looking clumsy, then you need to basically what I am doing here. I am taking the double. I wiped it out. Okay. So if you are not convinced, then start with this I into del y of omega 1 y minus omega 2 x minus del z of omega 3 x minus omega 1 z plus just wait, some noises are coming on. Yeah. So j into what will you get here? This into this into this. So del z of del z of omega 3 x minus omega 1 z. Oh, sorry, not omega, not 3. Sorry. This will be this into this, na? So omega 2 z minus omega 3 y minus here del x of
Omega 1 y minus omega 2
omega 1 y minus omega 2 x. Thank you. Plus k into del x of omega 3 x minus omega 1 z minus del y of omega 2 z minus omega 3 y. Now on simplification you are going to get basically 2 into omega 1 I plus omega 2 j plus omega 3 k, so that it will be twice omega vector, and this omega is basically, as I have told you, the angular velocity. So the angular velocity will be equal to half of the curl of the linear velocity v. Okay. Now if there is no angular velocity, that means there is no rotation, right? If there is no angular velocity, there is no rotation, and in that case what will happen? Omega will be equal to 0, so that the curl of v that is equal to 0. That will imply omega is equal to 0, and omega 0 means what? The vector is basically having no angular motion, right? If there is angular motion, then only you will get angular velocity. Since there is no angular velocity, therefore there is no rotation, and that's why for a vector, if curl of the vector v is equal to the 0 vector, then we say or we conclude the vector v is irrotational. Is that clear?
Yes, sir.
Sometimes
Yes, sir.
you will also see, or you have to prove basically, that a vector is irrotational. a very straightforward thing is that if you are having a surface, scalar surface, there the outward drawn normals, that is grad phi, that are what? That are having linear direction. There is no rotation over there. Okay, and in that case, basically the curl of grad phi, that is the outward drawn normal to the surface, will be always irrotational. So many times it is seen that you will be given a surface, you will be given a point. At a point you need to find that or prove that the surface is irrotational, or you need to find curl of grad phi at a particular point, any point, alpha, beta, gamma. So whatever may be the point given to you, at that point the vector field, in the vector field there will be no rotation, so it will be irrotational. And in order to check that, you may also check it in this way. So suppose you have a function phi1, phi phi is phi of xyz. Suppose you are having the function phi to be phi of xyz. Now whenever you will be finding, say, grad phi, what will you get? Del x of I plus del y of j plus del z of k operating on phi, that is del phi del x I plus del phi del y j plus del phi del z k. Del phi del z k. Now you try to find curl of grad phi. What will you get? I j k, then del x, del y, del z. Here it's del phi by del x, del phi by del y, and del phi by del z. So that it will be, if you expand, you are going to get I into, say, here del phi by del 2 phi by del y del z minus del 2 phi by del z del y plus j into del 2 phi by del x del z minus del 2 phi by del 2 phi by del z del x. Similarly, plus k into del 2 phi by del x del y minus del 2 phi by del y del x. So what you are getting here? It's not ordinary zero, it's a zero vector. Is that clear to all?
Yes, sir.
Yes.
So curl of grad phi is always zero. Basically, you see now, one, if you are having a surface, scalar surface, where from you will get a rotation, there is no rotation, right? And this, if for a vector, so this is a vector where I got curl of grad phi equal to 0, and for any vector, whenever curl of whenever the curl of the vector is equal to 0, okay, that means suppose you are given a vector A and you get curl of A that is equal to 0, then this A vector A, since this is equal to grad of this is also equal to curl of grad phi. So here from we can conclude that A can always be represented as this A equal to grad phi, where this phi is called scalar potential function. Okay. Now here from one kind of question that can be asked, very specific. you'll be given the vector A. You may also see in the practice sheet as well that A is a vector. Suppose A1I plus A2J plus A3K. A vector will be given in this way, and you will be asked that check or prove that A is irrotational. Or prove that curl of A equal to 0, and hence find phi such that A equal to grad of phi. Is the question clear?
Yes, sir.
So you will be given a surface, you will be vector, and that from that vector you need to find the surface for which curl of grad phi equal to or which is equal to curl of grad phi. Now how to prove it? Suppose, so here as you can see, I got what? A equal to A1I plus A2J plus A3K, and if this is equal to grad phi, then what will you get? Del phi by del xi plus del phi by del y j plus del phi by del z k. Okay. Till this point, any question?
No, sir.
No. So if you compare both the side, then what you are going to get? You see, del phi by del x, that will be equal to A1, del phi by del y will be equal to A2, and del phi by del z, that will be equal to A3. Fine. Now see, from each of the equation, so from equation 1, here this is 2, and suppose this is 3. From 1, what you are getting? This del phi equal to A1 del x. So whenever you will be integrating here this phi, on integration you will be getting this phi to be equal to integration A1 del x. Why I am writing del? Because I'm integrating partially here, treating here yz to be constant. Treating yz as constant, I'll be evaluating this. This A1 is basically A1 of xyz, but here yz will be constant because we are integrating with respect to x first. So here a constant will be, say, C1, and C1 is function of yz. Similarly, from the second equation, I will be getting del phi equal to A2 del y, which will imply another phi equal to here integration of A2 del y plus C2 of xz, where this is the x and z are constant. And similarly, from the last one, I will be writing del phi equal to A3 del z, which will imply phi equal to integration of A3 del z plus C3 of x comma y, where x, y are constant. So what will be then the phi? Basically, this will imply phi will be equal to whatever the common will be there in this and this expression. Write down the common term once, then the uncommon term plus uncommon terms, and then plus some constant c. That will be the function phi. Okay. I am taking a very small example pertaining to this particular problem. Say this is the problem from the book itself. It is given the vector A to be equal to 6xz plus zq I plus thrice x square minus z j plus thrice xz square minus y k. The question is that prove that or show that A is irrotational, and then prove that or find the scalar such that this A equal to grad phi. Is the question clear?
Yes, sir.
Yes,
Right.
sir.
Now you see how to evaluate it. So as I have told you, I have to first find this curl of A. I am telling you, if you find this curl of A, it is basically is going to be equal to 0 vector. Okay, you find it. Find first. Next, what you need to do? So since this is there, this is A is irrotational. So as A is irrotational, so what will happen? A equal to grad phi, so that this del phi by del x, that will be equal to 6xz
Exact
plus z
plus
cube, del phi by del y, that will be equal to thrice x square minus z, and del phi by del z, that will be equal to thrice xz square minus y.
sir.
Yes.
Sir, where will be the constant part?
Wait a bit. There is no constant. Till now there is no constant. Okay. Now whenever you will be integrating, because here we are doing partial integrate, these derivatives are partial derivative. So whenever you will be integrating here, integration of del phi basically, this is equal to what? Integration of 6xz plus z cube. You can write del x because you are integrating partially with respect to x. So what will be here? You see thrice x square z plus z cube x plus some c1 of yz, and you will write here yz are constants. Got it?
Yes, sir.
So phi equal to this. This is, suppose this is 1. You are writing 1 here. Similarly, from the second, that is integration of del phi equal to integration of here thrice x square minus z del y, and this will be basically thrice x square y minus yz plus c2 of y and z.
Z constant or y z.
Have I done anything
So
mistake?
এটা exit হবে তো?
Xz.
Sorry, which one?
C2 of the function of xz.
Oh, sorry, c2 will be function of xz. I have done a mistake. Where is the mistake? Do you know? This is not 6xz but xy. I think I have done the mistake earlier in the function itself. function what you have written? Xz, na? This will not be xz, this will be xy. Okay. Otherwise, there will be nothing common. Otherwise, there will be nothing common. So this will be y. Here y. So there you have got x square y plus this one, and the third one is what? Third one is thrice x z square minus y, that is del phi equal to this del z, that is here thrice z x z cube by 3, that is thrice x z cube minus yz plus c3 of xy, where xy are constant. Here here what was there? Xz are constant. Okay. Now you see, whenever I'll try to write then phi, so phi will be equal to, you see what are common? This is common to these two, so I'll be writing this once, thrice x square y. Then this z cube x, here z cube x, they are common, so that I have to write once. So x z cube or z cube x, and then minus, you see here this yz are common, so minus yz will be there, plus here the constant c will be arbitrary constant. C is arbitrary. Is that clear?
স্যার এখানে যদি একটা কমন পার্ট বাট সাইন যদি চেঞ্জ থাকতো, মানে মাইনাস ওয়াই জেড একটা প্লাস ওয়াই জেড থাকতো দেন?
তাহলে আলাদা আলাদা লিখতে হতো, সেটা কেটে যেত।
আচ্ছা,
yz যদি থাকে দেখবে কেটে যাবে, সেক্ষেত্রে প্লাস আর মাইনাস থাকলে কেটে যাবে।
ওকে স্যার।
জেনারেলি আনলাইকলি ওইরকম থাকবে না, হবে না কখনো। ওকে, ইট উইল নেভার হ্যাপেন, ডোন্ট ওয়ারি। Clear?
Okay,
Yes, sir.
So these are the different type of problem that you will get from the vector differentiation. Next, I'll be going for vector integration, and in your reduced syllabus you only have vector integration, the Green's theorem. I have tried my level best, but whether it is going in your head or not, that God knows. This is the last part, or maybe the last part of our syllabus. It is vector integration. Whenever you will be having an integration of this form, integration f dot dr over a curve C. Line integration I have talked about in a class. Line integration f dot dr. Now this curve will be a curve in 3 dimension. It will be starting from from initial point A, it will be going to B. It might be having the equation like phi t equal to 0, or it may be phi of xyz equal to 0. This type of curve may be there, this C. but sometimes it becomes very tough for us to calculate this. And for a very particular case, now we have talked about line integral. If it is easier integral, let's say you are starting with a point A, going to the point B, following some very simple curve. In that case, basically, whenever will be expanding it, it is going to be equal to some f1 dx plus f2 dy plus f3 dz, and you will be putting, whenever you will be doing this f1 dx, yesterday we have talked about this line integral. So this f1 dx you will be doing, f2 dx you will be doing, f3 dz you will be doing the way you have calculated line integral. But sometimes this becomes very clumsy, and even if it is given in terms of a closed circle or closed area bounded by a boundary curve, in that case there will be a tragedy for us. It will be very tough for us. So this type of problem is resolved by the Green's theorem, and this is for very particular type of problem, the Green's theorem. The Green's theorem says that let m xy, গোবিন্দ এতক্ষণ পর ঢুকলো, and nxy, mxy and nxy be two continuous function of x and y having continuous partial derivatives. Del m del y and del n del x. Suppose these two exist, okay, in a region R bounded by, no, and this R is not ordinary R, on xy plane bounded by a closed curve C. Then the closed integration over the curve C, m dx plus n dy, that will be equal to double integration over the region R, del n by del x minus del m by del y whole into dx dy. So basically what you are trying to find, a double integration in terms of line integral, and in the other way a line integral with the help of double integral, that you can do. So here from two types of question again you can get. One is that verify the Green's theorem, and second type of problem is that evaluate this m dx plus n dy by Green's theorem, or the question will be in the other way, that evaluate double integration, this one, del n del x minus del m del y dx dy by Green's theorem. Okay, Now what is the difficulty in it? There is no difficulty. If you are given a line integral, if you need to verify it, for verification from both the way you need to calculate, and if you are not given to verify but to evaluate, in that case you need to simply integrate it. Okay, so let us take an example and evaluate it in both the way. So I'm directly doing the verification problem, then I'll be segregating both the problem. So the question will be, verify Green's theorem in plane for integration, closed integration over C xy plus y square dx plus x square dy, where C is the closed curve of the region bounded by y equal to x and y equal to x square. Chalo. So let us try to solve this particular problem. Now in order to find the solution to the problem, what you need to do, first of all, you draw the region. The region is bounded by two curves. One is that y equal to x. I can draw this curve. Sorry, my drawing is very poor and it is again coming with a tragedy. Okay, suppose this is y equal to x and this is y equal to x square. Okay, roughly y equal to x and this is y equal to x square. So the region of integration or the curve is this one. Yes, Rajnish, what you want to say?
Nothing.
Oh, your hand has raised, so that's why I'm asking. Okay, fine. So by Green's theorem, what I know that closed integration over C m dx plus n dy, that is equal to double integration here del n by del x minus del m by del y dy dx. Now closed integration over C, this m dx n dy. Now what is the given problem here? The given problem is closed integration over C, it is x square, sorry, xy plus y square, this dx plus x square dy. Now here from what I can say, that m equal to how much? Xy plus y square and n equal to x square. So that del m by del y, what will be that? Xy plus twice y and del n del x equal to twice x. Clear? Okay. This is del n by del x. Now whenever we will be trying to find the double integral,
হচ্ছে ওখানে শুধু x হবে না,
কোনখানটা?
del m by del y.
Oh sorry, del m by del y এ শুধু x হবে, শুধু x হবে. Thank you. শুধু x. Only x. Fine. Okay. Now, whenever you will be doing this del m by del n by del x minus del m by del y, what you are getting here? This twice x minus twice y. Now this you will be doing double integration dx dy. Here double integration dx dy over the region R. Okay, so that will be basically double integration over the region R. It is x minus twice y dx dy. Okay. Now what will be the range on R? X of range of, that means limit on x and y. Can anybody tell me? So I want to take the range on y first. So then y will be going from where to where? As you can see, y will be going from x squared to x, and x will be going from 0 to 1, because that these are the point of intersection, right? This is x minus twice y dx dy or dy dx. Now you integrate with respect to y first, because limit on y is there first, so you have to first integrate with respect to y. So what will be y? So basically here you will have x equal to here 0 to 1, then rest of the part is x is xy minus twice y square by 2, limit x squared to x here dx. That will be integration x equal to 0 to 1, then this is the value what? X into, it will be x minus x square minus here y square, means x square minus x to the power 4. Is that okay to all? What I am trying to say here, x equal to 0 to 1, then this is basically x square minus x cube minus x square plus x to the power 4 dx. What will you get? X to the power 5 by 5 minus x square will cancel each other, so x to the power 4 by 4, limit 0 to 1, so 1 by 5 minus 1 by 4, what is that? Minus 1 by 20. Okay, this is the answer to the problem evaluate by Green's theorem, or even the right hand side of the Green's theorem. That left hand side is this, the right hand side is what? Del n del x minus del m del y, that we found as minus 1 by 20. Now for the second part, means if we want to find it by the line integral, basically integration this over c xy minus xy plus y square dx minus or plus x square dy. If we want to find it by with the help of line integration, then you see you have to first take line integration over y equal to x square, then y equal to x. Now whenever y equal to x square, in that case, so on, suppose this is the curve C1, this is the curve C2. So on C2, on C1, y equal to x square and x changes from 0 to 1. So I am converting everything in terms of x, so that this dy will be equal to twice x dx. So basically here you are getting y equal to x square. So this is be x cube plus x to the power 4 dx plus x to the power 4 into twice x dx, right? Okay, so what you are getting, twice x to the power 5 plus x to the power 4 plus x cube integration x equal to 0 to 1 this dx. On integration, what you are going to get? 1 minute. 1 minute. X to the power 4 is okay. Why I am writing here x to the power 4? This will be x square only. This will be x square only. No? Here the x square you are having, not x5. This is twice x to the x, twice x cube, right? So 2 and 1, 3, thrice x cube. So it will be x to the power, so twice thrice x to the power 4 by 4 minus x to the 5, sorry, plus x to the 5 by 5, 0 to 1. This will be 3 by 4 plus 1 by 5, right? 3 by 4 plus 1 by 5. This is on the curve C1 and on the curve C2. On C2 what will happen? Y equal to x and x changes from 1 to 0, right? X changes from 1 to 0, and in that case what will happen? You see, integration this x into x plus y equal to x, so x square dx plus, here in this case x square will be y square, dx will be dy, sorry, dy will be equal to dx. So ultimately what you are getting, x square x square x square, so thrice x square integration dx. What is the value? It is thrice x cube by 3, that is equal to 1, means x cube. Have I written correct? 1 to 0, that is 1 to 0 means it is minus 1. So what will be the ultimate value? So closed integration over C, this one, xy plus y square dx plus x square dy, that will be basically 3 by 4 plus 1 by 5 minus 1, that is how much? 3 5 is 15, 15 plus 4 minus 20 by 20, that is minus 1 by 20. So you see the left hand side equal to right hand side. So the Green's theorem is verified.